All right. Well, the My Open Math practice problems that I put onto Canvas are split up into polynomial and rational separately, and there might be even some mix of non-polynomial things. But I'm going to start here with just a basic introduction to inequalities, how to solve them algebraically, and how to solve them graphically. So we're going to start with two simple examples that are actually from previous material, one we haven't even reviewed. So first idea is just a linear inequality. So when we're talking about a linear inequality in a single variable, we could be talking about something like 3x minus 5 is greater than 7. Just going to make up some numbers. So for an inequality like this, we know how to solve this algebraically, right? It's all about our thing we normally do in an equation, isolating our variable. And we could do that by just, I mean, you're a pre-calculus class. You don't need to watch me make these steps, but I am a glutton for punishment and I really enjoy showing work, so I will do this. So we get out our final answer of x is greater than 4. Now, the reason I want to talk about this question, as simple as it is I want to talk about our solutions, and I want to talk about also how to solve this graphically, because we probably always revert to our algebraic way to solve it because it is something we learned. But first, solutions. What is listed here is not considered a solution. It's a rule, it's an inequality, but it's not a solution. We have two ways that we can make this obviously a solution set. One is to use what we call set builder notation. So typically when we're talking about solutions, when there's more than one, we put them inside of these squiggle brackets, right? These things called braces. Um, and in this case, there's a number of things that are solutions. So the way we would write this in set builder notation is to write this. This is telling us in math terms that any x is a solution as long as, that's kind of what this line says, if this is true. This is the condition. If x is greater than 4, then it's in my solution set. So that is set builder notation. This is not a notation you see much after an algebra class. After algebra, we move into interval notation, which is what we've been using. So I'm not going to spend a ton of time on it, but in this case, we will be talking about 4 to infinity as a solution, not including the 4, so we use our parenthesis. And remember, if you need a stepping stone along the way, you can always make yourself a quick little number line. We've got 4, and in this case, we're looking at greater than 4, so we're going in that direction. And that really helps students make that transition to the interval notation, because we know if we go to that arrow, we're going to infinity and vice versa. And it should always be in that order of the smaller number and then the larger number when we're talking about interval notation. Most common errors I see are to students flipping those two numbers when it really does matter. So that's the algebra you already knew. 3 minutes to talk about stuff you already knew. Now let's talk about the graph of this. So what the graph of this looks like. You have two ways you can do this. You can make the graph at any point. I tend to find it makes the most sense to graph each of these two things separately, right? Just like we solve an equality or an equation with graphs, we can solve our inequality with graphs. So we would want to graph both of these things. So I'm going to go ahead and I'm just going to write two different things. We have two different functions. We have, a f of x, which is our left function, right, that left side, which is this linear function, a line, right? We could go ahead. I guess I'll try to be good. It's going to be a bad, you guys know, I'm not very good at drawing graphs on the fly. They're always real wonkadoodle. I need to go all the way to -5. Boop, boop. So we're at -5, then we have a slope of 3. So up 3 over 1, up 3 over 1, up 3 over 1. There's my beautiful f of x. I should have used yellow. It's too late now, but I should have used yellow. Um, and I also did a terrible job of drawing my line. So, eek, it's getting worse. I should just give up. Start. That's fine. All right, so there's my f of x. And then we have another function, which is our g of x, that right side, which is just 7. Y is equal to 7. That's a constant function. So at 7, we're just going to come in here and draw, oops, that's terrible. Draw a straight line, 1, 2, 3, 4, 5, 6, 7. draw a straight line, right? Our slope is 0, our horizontal line. So we got our 2. And so when we're talking about this, right, if we were looking for the actual solution to this, if this was just an equation, we would be able to see our solution there. We have this point, what is this point? My God, 4, comma 7. That is a solution to both of those functions. Now, what does this mean in an inequality land, right? If this was an equation, we would be able to just say the answer is 4. It's asking what x is. We don't care what y is. Y is the output when x is 4. That's what they are both at that moment, but we only really care about the 4. So then we get one more piece to this, and the last piece to this is to look at that greater than sign. So the greater than sign is telling us that the f of x is above. We're asking, when is f of x? That's the question that this is asking us. When is, and when is always about x, f of x above g of x? When is my blue line, which I should have written my f of x in blue so that this was more obvious. When is the blue line above the green line? And so hopefully we can see this whole section of the blue line is above the green line. And then we have to remember, when is about x's, right? When is about x's. So we go down here, we go, whoop. The x's where this is possible is anything there. We can bring down that point at 4. We have an open circle because that 4, they're exactly the same. That's not what we want. And then everything to the right. That's when my f of x is above my g of x. So this is graphically what it is that we're solving, and it's nice because here we can actually see there's that 4 to infinity on that axis. This is definitely a question I could ask within my open math or on that take-home section. I could give you a drawing of a function. I could tell you, okay, let's call this thing f of x. Let's call this line g of x. Let me add some, finishing my x's because my pen just did not function properly on those two x's. And I can add some tick marks to my axes, 1, 2, 3, 4, 5. So let's say that this is happening at 5. And if I give you the question, f of x is less than or equal to g of x, you could solve this graphically, right? You can look at the graph. You know f of x is the blue line. You know g of x is the red line. And you know less than means that we are looking for moments when we are below, when the blue line is below the red line. And so we can look at this and we say, oh, all of this section of the blue line is less than or below the red line. And so then we just do that, bring this down, this point at 5, all of this section of x's, because the when is what we're asking. And we look, it has an equal to, so we're going to fill this circle. So you don't have to be given the functions. You can go ahead and solve this question just looking at the two graphs. And this is where, again, the power of Desmos and something that graphs for you is really quite lovely. Because even if we had something that wasn't set equal to 0, we don't have to do all of this solving. All the steps algebraically are very challenging, where here I can immediately see negative infinity to 5 is my solution set, right? That's when that f of x, that blue line, is below the red line. So that's the basics of our inequalities. In terms of solving them algebraically, if we have a very simple linear, and then solving them graphically. We're going to move on. I'm going to do one more example of sort of the basics with an absolute value function. We've already seen it, but looking at interval testing as a way to see this, and then we will move on to our polynomials and those rules.